crazy red elk is at it again, right? So this time he's jumping off a cliff into water, right? So let's draw a picture of this. There he is. And he's running 4.5 meters per second, and he lands 6.2 meters from the base of the cliff. Interesting. This is 6.2 meters. That's what we mean, right? We don't know the height of the cliff, which is interesting, but we do know how fast he's moving. Let's see what this does here. Okay, now, in any cliff problem, there is no acceleration or any projectile motion. There's no acceleration horizontally. There's always gravity acting vertically, right? Okay. Because he's running horizontally, I'm going to say that the initial vertical velocity is 0. Okay, that makes it a cliff problem right there. All cliff problems will be like that. Okay. There must be something else we know. Oh, here. The 4.5 horizontally, that must be my initial velocity, right? Okay. And then the 6.2, that's a horizontal distance, right? So that I can fill that in. Now, let me just give you a clue. If the initial velocity is 4.5 meters per second and it can't change, there's no acceleration, the final has to be 4.5. In fact, when you fill these in, you'll learn this, right? These guys are always the same. They're always the same. Okay, so if you know this one, you know this one. Okay, or vice versa. Okay, now I can't do anything vertically here. I only know two things. I don't know the height of the cliff, don't know how fast it's going, don't know time, right? Here I know everything except time, right? And I'll give you this clue. The only formula you ever use in the horizontal direction is x is vit. Because all we have is just a constant horizontal velocity. There's no acceleration. It's like the first day of school. So the first thing I'm going to do is find that time, right? I can go 6.2 is 4.5 times t, and then I can solve for t. T is equal to 6.2 divided by 4.5. Oh wow, 1.37 bar. Ta-da. It's a lot of sevens, right? That's a convenient number. It's easy to type in, right? I'm going to store that in t on my calculator. Okay, now I can slide that t across. So this is 1.3777777777 seconds, right? Now I'm in luck, right? Now I can solve this side. I've got 1, 2, 3 things that's solvable, right? So for my final vertical velocity, I'm going to choose VF is VI plus AT. Let's see, VF is 0 plus negative 9.8. Negative 9.8 times 1.37 bar, right? So negative 9.8 times the answer I just got is negative 13.502 bar. This is meters per second squared, right? All right, so let's see. Okay, and then let's see if I can find x. I'm going to choose to use the time to find x. So I'm going to use x is VIT plus 1/2 AT squared. So x is 0 times 1.37 bar plus 1/2 negative 9.8 times 1.37 bar squared. Now, 0 times that isn't 1.3777. 0 times that is nothing. There's nothing there, right? So I'm simply going to do this. I'm going to type this into my calculator. 0.5 negative 9.8 times 1.37 bar squared. Okay, so 0.5. Oh wait, why did I say 0.15? 0.5. Sorry, that's 1/2. Okay, so 0.5 times negative 9.8 times, and then really I'm just going to type alpha t. Okay, you would type, what you would want to type is at least like 1.37777 or something like that, right? Okay, there's a trick to that. Okay, I'm getting that x equals negative 9.3015 meters. Okay, so let's see what questions we've answered. Let's see, time is in the air. I think the answer to A is 1.38 seconds. All right, the answer to B, what is his final vertical velocity? I guess negative 13.5, right? That's the vertical side here, that's the velocity. So final vertical is minus 13.5. Okay, C, how tall is the cliff? Well, notice how we have a negative displacement here. That's because what we're saying is that Red Elk displaces himself down 9.3 meters, right? But we wouldn't say that the cliff is negative 9.3 meters tall. We'd say that the cliff is 9.30. We'd leave it as a positive number. It's meant to be sort of like how big it is, right? Okay, now, what is the velocity of impact in terms of an angle and a magnitude? We can draw a picture of that, so let's do that. Okay, so over and down, right? We're going to take this guy here, the final velocity. It's always the final velocity that we do. Okay, and we draw a picture of it. So let's go over. Let's go down. Notice I took great pains to make this look bigger than the over, right? That is the velocity. You guys know how to do this, right? So this is 4.5 exactly. This is minus 13.502 bar, right? And then we can find this angle, right? That angle there is tan minus 1 of the opposite over the adjacent, right? This is opposite, that's adjacent. So 13.502 bar divided by 4.5. All right, let's do that. Second tan of 13. Notice I'm ignoring the minus sign there because I really don't know what to do with that. Okay, 13.502 divided by 4.5. I typed a bunch of 2's, you can't tell. 71.6 degrees. All right, so that angle right there is 71.6 degrees. And then we can find the magnitude of that. That's going to be the speed of it, right? So the magnitude of this velocity vector is the square root of 4.5 squared plus 13.502 bar squared, okay? Don't put the minus sign in here. I promise you it'll get you into trouble because TI calculators are curious when you square negative numbers. All right, square root, it interprets them interestingly. 4.5 squared plus 13.502222222 squared. I get 14.23. So this hypotenuse is 14.2 meters per second. So the speed of this thing, or the magnitude of the velocity vector, is 14.2 meters per second. Alrighty. I think that's a take, right? So to answer this question, you would draw a picture of this velocity vector. You would label that angle 71.6 degrees. You'd label the hypotenuse 14.2 meters per second. And you'd smile. So that's the answer to D. Having accomplished so much.